So this video is on how to complete a two-column proof. When we do a two-column proof, we always start with given information and work down to a proof step. The first statement is always the given information. The first reason is always the word given. The last statement is typically the statement after the proof. Each statement that we write is developed by using previous information that we have in our proof. And for these skeleton proofs that we have where some information is given, we can use the reasons or statements as clues for what we should fill in. So we're going to get started with the first proof on your sheet. So when we look at this proof, if ABC is a right angle, we have to prove that angle ABD and angle CBD are complementary. Like I said, the first thing we want to put in here is the word given. So we want to put in given. And then we need to justify step 2, statement 2. So you can see that where it says reason, we have definition of a right angle. Now we say definition of a right angle. A right angle is an angle that has a measure of 90 degrees. So that's what we're going to put in. So we're going to put the measure of angle ABC equals 90 degrees. So that's what it means to be a right angle. So statement 1 directly helps us fill in statement 2. If angle ABD is a right angle, it means that the measure this should be ABC, excuse me. If ABC is a right angle, then the measure of angle ABC should equal 90 degrees. That is the definition of a right angle. And so when I say we want to use clues to help us fill in the rest of the proof, you can see where we have this angle addition postulate. That's going to tell us what we should have in the blank for statement 3. So if we look at the picture that we have, we can clearly see that angle ABC is composed of angle ABD and angle CBD, meaning that we want to write in that the measure of angle ABD plus the measure of angle CDB equals the measure of angle ABC. That's a true statement. It's what we call an angle addition postulate. Again, we can clearly see that to get all of angle ABC, we would have to add the measure of angle ABD and the measure of angle CBD. Now, if you notice in step 4 or statement 4, we go from having the exact same thing on the left side in both statements to where on the right side we go from measure ABC here down to 90 degrees. Now, if we look back at statement 2, we clearly see that the measure of ABC equals 90 degrees. So it seems like we substituted 90 degrees for the measure of ABC in that step. So what we're going to write down is substitution. And also, I guess we want to fill in this in red because that's also information that we introduced in. And so lastly, remember we said that the last step is always the prove part. What comes after the prove? So here, this is what comes after the prove. So we're just going to copy that and we're going to paste it in. And so that's our proof. Now we can clearly see that if the measure of angle ABD plus the measure of angle CBD equals 90 degrees, that is the definition of complementary angles, two angles whose sum is 90 degrees. So that completes that proof. What I'm going to do is move down to the second proof. And we're going to do something slightly different, where you notice that on the right side, we're giving all of the reasons and we have to come up with all of the statements. So first, let me set this up so that everything that we type comes in red. All right, so now the first reason, always given. Always given. It's just given. The first statement is just the given information. We're going to copy that. We're going to paste it in. And so we just put that information in. But now we have to justify statement 2 by using statement 1. So for statement 1, we have angle 1 and angle 2 are congruent, and angle 2 and angle 3 are congruent. What does it mean for angles to be congruent? If angles are congruent, it means if angle 1 is congruent to angle 2, it means that the measure of angle 1 is equal to the measure of angle 2. And if angle 2 is congruent to angle 3, what that means is the measure of angle 2 equals the measure of angle 3. That's what it means to be congruent. That's the definition of congruent angles. They have the same measure. So now for statement 3, we see transitive property. Now remember, the transitive property is A equals B and B equals C implies that A equals C. That's the transitive property. So now if we look in the second statement, we see that the measure of angle 1 equals the measure of angle 2, and the measure of angle 2 equals the measure of angle 3. What we can reasonably conclude is that the measure of angle 1 equals the measure of angle 3. That's the transitive property. If the measure of angle 1 equals the measure of angle 2, and the measure of angle 2 equals the measure of angle 3, we can reasonably conclude that the measure of angle 1 equals the measure of angle 3. And so for our last statement, we see that the reason is definition of congruent angles. And again, if angles are congruent, it means that the measures are equal. And so we can go backwards using the converse of that statement, saying that if the measures of two angles are equal, then the angles are congruent. So then we can deduce for statement 4, the prove step, which is always what we put in last. So we write in our prove step, and that completes this proof. All right, so what I want you guys to do is, for the rest of the class, complete the other 4 proofs. Now you notice we go into segments as well, but those proofs work just like this, where we're using other information, geometric information, and some algebraic steps to justify proofs. We will go over this stuff in class on Monday. Bring in any questions and have your proofs completed. Thank you.